Circle theorems. Theorem 5. This theorem relates to Theorem 4, in the sense that there are 4 points in the circle, but instead of forming a cyclic quadrilateral, the opposite points join each other and 2 chords are created. When we have a structure like this, 2 triangles are formed. The relationship between these 2 triangles is that they are identical but mirrored, and usually a different size. What this means is that angle DAC equals CEB. ACD equals ECB. And angles ADC equals CBE. Alright, look at this example. If angle ABC equals to 30 degrees and angle DCE is equal to 110, what does angle BAC equal to? As we both know, these triangles are the same but mirrored. So that means angles ABC and CED are equal to each other. Also, angle ACB is equal to DCE, and angle BAC is equal to CDE. As you can see, we know the sizes of the majority of the angles on both triangles. All that is left are the 2 unknown angles that equal each other. To find angle BAC, we just take the sum of 30 plus 110 away from 180, which is equal to 40 degrees. Circle theorems. Theorem 6. We know from Theorem 4, the opposite angles on a cyclic quadrilateral add up to 180 degrees. And we also know that all angles on a straight line also add up to 180 degrees. Then the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. As you can see, it's all about 180. They both have to be equal to each other. For example, if angle ABC was equal to 97 degrees, what is the size of the opposite exterior angle CDE? Since ABC equals 97 degrees, then the opposite exterior angle must equal 97 degrees. It's the same as the exterior angle as it is on the straight line. Circle theorems. Theorem 7. Before going through the next theorem, a couple of things need to be understood. First, a tangent is when a straight line meets a curved object, or a curved line. In this case, it meets the circumference of a circle. Secondly, the angle between the tangent and the radius, when they meet, is always equal to 90 degrees, regardless where the radius is, which therefore means the radius is perpendicular to the tangent. If 2 tangents were drawn on a circle, the lengths of the tangents from the circumference to where they meet will be the same. Since we know that the angle between the tangent and the radius equals 90 degrees, then the angles BAC and BDC are both 90 degrees. Since we now have a quadrilateral, that also means that angle ACD and DBA add up to 180 degrees, since we already have two 90 degrees. For example, lengths AC and CB are both tangents. Lengths XY and YZ are both radii. If angle XYZ equals 85 degrees, what does angle XCZ equal to? Since we know angle YXC and YZC are both 90 degrees, the last two angles add up to 180 degrees. XCZ must equal 180 minus 85, which is 95 degrees. Circle theorems. Theorem 8. There's a reason why this theorem is last. It's the hardest to visually grasp at times. The angle between a tangent and the chord is equal to the angle in the alternate segment. Yeah, I know, a lot of words. This basically means if you take the tangent of a point on a cyclic triangle, these two angles will equal each other. The same applies to these. It goes back to the rules of 180 degrees. All the angles on a straight line add up to 180 degrees, and all the angles on a triangle add up to 180 degrees also. For example, if angle ABC is 45 degrees and angle BCD is equal to 60 degrees, what does angle CBD equal to? From what we've learnt, we know these two angles are the same. Once again, we use the 180 degree rule. To find CBD, we subtract 45 plus 60 from 180, which equals 75. If you like this series, be sure to comment, like and subscribe to be kept updated on new and in-depth videos, and most importantly, share. I mean, what's the point of knowledge if you can't share it, right? And if we can make some people not give up on maths because of these videos, then our job is done. Don't see a topic you need help with? Suggest topics in the comment section below.